Hi and welcome. I'm trying to learn Biographyology, today Paul Dirac, and after we've done it, we're going to do Extensor, Carpi, Ulnaris strength training. And if you participate in the Extensor, Carpi, Ulnaris strength training, that's really honest. The Extensor, Carpi, Ulnaris muscle and tendon are here. Now, Paul Dirac. Paul Dirac's equation predicted the existence of antimatter. So, there's antimatter in the universe, there's matter and there's antimatter. There's basically almost everything which exists has something opposite to it. There are protons in the universe and there are antiprotons. That was it over here. The most basic definition of an antimatter particle is that it is the same as a matter particle, except that it has the opposite charge. So the familiar electron, for example, with a negative charge of -1, has an antimatter equivalent called a positron that has a charge of +1. So basically for every electron there's a positron. And Paul Dirac made a mathematical equation about it. We are doing the antimatter in particle physics. We haven't come so far to see the equation, so I don't know what it says. The strange world of Paul Dirac, but we're here for biographyology. Stories of the eccentricities of Paul Dirac, who lived from 1902 until 1984, and was the British physicist whose eponymous equation predicted the existence of antimatter. I don't know the word eponymous. Okay, what we said was that Paul Dirac lived from 1902 until 1984, that he was from Britain, and he was a physicist, and he made a mathematical equation. He wrote something down, and it predicted that said there is antimatter. It was later actually also found. Right, I think. It wasn't found. Dirac was notoriously taciturn. I don't know what the word taciturn means. When he first visited the institute led by pioneer of quantum theory, Niels Bohr, in Copenhagen in the 1930s, his reported utterances consisted almost entirely of three phrases. He used the three phrases yes, no, and I don't mind. Okay, what was he told? He visited the institute in Copenhagen. I think that's in Denmark. In Copenhagen in the 1930s. And that was led by Niels Bohr and another physicist, chemist. And there he used only as his words yes, no, and I don't mind. We're going to use it later as these three anecdotes I think we're going to tell. Later he became more flexible. When astrophysicist Subramanian Chandrasekhar expounded his use, now I'm a little bit stuck because we read it already in particle physics, but now I want to be able to repeat the name without reading it. Subramanian Chandrasekhar. No, Subramanian Chandrasekhar was holding a speech or lecture, and when Dirac used repeatedly the interjection, yes, but he explained when I say yes, I don't, it does not mean that I agree, it means only that you should come on. Okay, when Subramanian I know the poet Subramanya Basho. Subramanian Chandrasekhar. Okay, when Subramanian Chandrasekhar was holding a speech, what was it? Expounded his views, holding a speech. Where Paul Dirac was interrupting him with the interjection yes, but he explained then that it was not an interjection to say, to deliver agreements, but it was to signify that he wished that the lecture would continue of Subramanian Chandrasekhar. In 1929, Dirac sailed from the US to Japan with Werner Heisenberg. During the trip, Heisenberg spent the evening dancing while Dirac looked on puzzled. Okay, in 1929, he sailed from the United States to Japan with Werner Heisenberg. And while Werner Heisenberg was basically partying, Dirac was more or less just thinking. I'm going to say thinking. Eventually, Dirac asked his friend why he danced. And Heisenberg replied then, well, when there are nice girls, it is a pleasure to dance. Then Dirac thought for 5 minutes. After thinking for 5 minutes, Dirac said, but how do you know beforehand that the girls are nice? And whatever the answer to that question, Dirac had a keen eye for mathematical aesthetics. When asked what led him to the equation that bears his name, he replied, I found it beautiful. Now, they didn't tell you in that book that he had the equation right after it. I assumed when I read it last time, this next year, but immediately in that moment where he said that, but how do you know beforehand that the girls are nice, that he had then the idea for what the equation is. No, but it's not written here like that. And now when I pay attention to it, I'm not even sure if it is meant of it. Whatever the answer to that question, Dirac had a keen eye for mathematical aesthetics. When asked what led him to the equation that bears his name, he replied, I found it beautiful. Most particle physicists wouldn't demur, I don't know what demur means. Regarded as the greatest British physicist since Isaac Newton, he is honored by something in Westminster Abbey, on which stands that very equation. No equation does not stand here. Okay. Now a big problem is, do we tell that anecdote about him with Heisenberg sailing to Japan and going to a bar? If it is not immediately related to his discovery of the equation, then it doesn't really make sense. But we're here for biographyology. It is a description of one event, one incident which happened, and we're here for biographyology, where we also maybe want to talk a bit about the character which he displayed. So why not mention that anecdote? Okay, we have it all together. Am I able to say? That is a big question, and we're already at the end of our time. Paul Dirac. Paul Dirac was born 1902, and he was from Britain, and he was a physicist. But what do we go on? When do we go on with? We're going on with, and he wrote an equation to predict the existence of antimatter. Basically, everything which exists has an opposite part. An electron with the opposite charge. An electron, which has a charge of -1, has its counterpart of plus with a charge of +1 and is called a positron. Let's go back to it for a moment. The most basic definition of an antimatter particle is that it is the same as a matter particle, except that it has the opposite charge. So the familiar electron, for example, with a negative charge of -1, has an antimatter equivalent called a positron with a charge of +1. We're going to stay with that, we're going to say that one example, nothing else. I want to say the same. We're going to stay with that. Now, and there are a few anecdotes also about his character written. In one incident, he went in 1900. In the 30s. What was in the 30s? In the 30s to the University of Copenhagen in Denmark. I'm just going to say it. I'm pretty sure it is Denmark. In Denmark, under the leadership of Niels Bohr, was the university. And it is said that he only used 3 ways to other himself, and they were yes, no, and I don't mind. Yes, no, I don't mind. And at another incident, is told that he was when he was listening to Subramanian Chandrasekhar talking, that he interjected with the words yes, but he meant actually, which you then explained, that he wished Subramanian Chandrasekhar to continue. But it wasn't showing his agreeableness, but he wanted him to continue. Another story of his life is that in 1929 he sailed from the United States to Japan together with another physicist, his name Werner Heisenberg. And while Werner Heisenberg was doing holidays and he was dancing, Paul Dirac was more or less just sitting there and thinking. One occasion he should have asked, it is told that he had asked him that he was asking Werner Heisenberg why he is dancing, and Werner Heisenberg said, because it makes fun to dance if the company is nice, whatever. It was not a direct words. Do we quote directly? In a way, yes, it's a nice example for biographyology. And the response of Paul Dirac was then, but how do you know that the company is nice beforehand? And when he fought for quite some time longer, and then he said that, so it was in the meantime, well, when there are nice girls, it is a pleasure to dance. But how do you know before that the girls are nice? Just 2 words, okay, just 2 sentences. And it's also said, and he had a keen eye for aesthetics. Can you say it like that? Dirac had a keen eye for mathematical aesthetics. and he said over his equation, for example, when asked how he found it out, that he found it beautiful. Maybe I'm going to say that a bit earlier, but it's someplace we maybe should mention that he is honored with inscription in Westminster Abbey in London, which bears beside his name. Do we just claim that it doesn't really make sense that it's not written there with his equation in Westminster Abbey. That was not a presentation. I'm going to do it in the next part. Now that was the biographyology part. If you were here for biographyology, you can go directly to the next part of biographyology. We will do now the Extensor Carpi Ulnaris strength training. If you stay and participate in the Extensor Carpi Ulnaris strength training, then it's the hours. And we are starting with. If you participate in this with the arm risk, we're having the hands next to us, palms of fists, and we're bringing them down and up, holding it a bit, and then again down the flat gate. Now, and we're having 3 rules. The first rule is that we're stopping immediately as soon as there's pain. The second rule is that we're we're going to the next exercise. The second rule is that we're going only as fast as we can go a little bit of effort. Now the hands next to us, we counterfeit money check and bring the fists up. And again down. And the third rule is that we're not overdoing it. We just want to strengthen to exhaust. And now we're going on. I'm going to use a sock. You're going to use something else. You press with full force onto it, and when you bring the wrist down, hold it. And up and hold it. Now, again, the 3 rules are important. If there's pain, then stop immediately. And second rule, go only as fast as you can go with a little bit of effort. Third rule, you don't want to overdo it. Stop before you overdo it. So just strengthen, not exhaust. And again, and also we're a bit behind time. On the other side, press with all 5 fingers equally forward. Go down because we want to strengthen the extensor carpi ulnaris. And up. And another. So another. And now the next exercise. Press again, go to the equally with all 5 fingers and turn it to the outside in supination, hold it, and again to the inside. Go only as far as you can go with a little bit of effort. And if it's pain, stop immediately to the inside and to the outside. Right time, the outside. And we can to the outside. And to the inside. And now from the top holding and bring the wrist up and follow the flexion. Again up. And with the other hand, press again equally with all 5 fingers and down with the wrist. And again up. Down. And we're ending, just press with good force with all 5 fingers equally. Land on the other side. And that was the Extensor Carpi Ulnaris strength training. I thank you very much and until next time.